8.1 homework video. I'm just going to go and solve the odd problems. And so a lot of these are dealing with solving triangles. We've solved triangles before. We're solving for our three sides and our three angles. But here they're not right triangles. So we're using this thing called the law of sines. And here's the law of sines. As long as I have three of the parts, I can solve for the other three. Okay, so as long as I have little a, side A, and side B, and one of the opposite angles, either opposite angle, opposite side of little a would be angle A. So if I have that one, I can solve for B, or if I had B, I could solve for A. But I need three of these parts, right? If I had the two angles A and B and side A, then I could solve for B, right? Or any of these are equal to even side C. So if I have any three pieces, any of these three pieces, or I can flip, right? I can flip this fraction. So I can flip this fraction, or I can flip this fraction. So we'll use this to solve for our angles. There's three different cases, or to solve for our triangles. There's three different cases dealing with side, angle, side. So if you're given two sides and an angle, the angle in between those two sides. So it's used to solve for side, angle, side. It's also used to solve for angle, side, angle. And then the hardest one, it's called the ambiguous case, is when we're given, well, there's actually two more cases. There's side, side, side. So we can solve for that. And then this one, where the side is in between. Okay. So where the side is in between, that's fine. And where we have the angle in between our two sides, that's okay. And side, side, side is okay. The one that's not, the case that comes up, is when we have two sides and an angle. Then we have a little tricky thing going on. We have, it's called the ambiguous case. So it has a potential of having one triangle, two triangles, or three triangles. Or not three triangles, sorry, no triangles. I just got in a roll there. Okay, so we'll go ahead and solve these, and then later on we'll deal with solving for area. Okay, so you can draw your triangles. They're not right triangles, but so however you want to draw them, three sides, right? So label your side C, so this must be little c. If this is A, this is little a, this is B, this is little b. Okay, and then label them. And then little c. And identify kind of what case are you dealing with. So I have two angles and a side, right? So I have angle, angle, side. Side, angle, angle. Now that one's the same. That one's the same as this one. So two angles are okay. It's when I have two sides that I have a little tricky thing. Okay, so that's fine. And now we can go ahead and solve. We can use our law of sines. I have, you first want to kind of look for the side that's, do we have an opposite side and an opposite angle? So where you're given two letters that are the same basically. And that's where you want to start. So these two are the same, so we're good there. Okay, and then you want to look at your third thing you're given. Okay, so we're given an angle B. So that means I want to solve for the opposite side of that. Okay, so whatever the third thing that you have is, that's not the same. You want to solve for the opposite side of that. So here it's a side, so I want to put B on top. Sine of B is going to go on bottom. Then C. Okay, and then I can just fill these parts in. So C is 45.38. Angle C is 74.08. And then B is 69.38. Okay, and now I can just solve an algebraic equation, multiply both sides by sine. of 69.38, sine of 69.38, right? So now I can just do this, and I'm probably going to round this answer, right? So when I round this answer, then I probably don't want to use this in order to solve for the next part, okay? So I'm going to go ahead and do the calculator here. I get 44.17. Okay, so there's my B, and now I need, so I have my little b, I have my c. Okay, I don't have a though, right? So I need to solve for little a, and I need to solve for big A, the angle. And I have big B, and I have big C, right? So I need to solve for these two. Well, I can just set it up for what I already know. I already know the two that I have, right? So I'm going to use those two. Now I want little a and big A, right? But I have two missing pieces. Well, don't you know, remember a triangle? Three angles add up to what? 180, right? So I can take my 74.08, my 69.38, and go ahead and find my A, which is 36.54 degrees. So now I can plug that in. Now I can multiply both sides by that. Sine of 36.54. And then I got my little a, which is 28.10. If I'm doing proper sig figs. So there you go. So there's my whole triangle, right? I got my three sides and got my three angles all done. Okay, so on this one we have two sides and an angle, right? So that leads us side, side. We can have side, side angle, which is the ambiguous case. Or we have side, angle, side, which is okay. Okay, so we got to find out if that angle's in between. So we can draw our triangle. Just say that's C. So we're given C. We're given C. And then we are given angle A. So this is angle A. Oh, we're given side A. So the angle that we are given C, it is not in between our two sides, right? Our two sides would have to be here and here. That's our angle C. Okay. Or I mean, I could have put angle A up here, and this would have been side C. But again, this angle that we're given is not in between. That'd be A. Sorry. That angle C that we're given is not in between the two sides. So this is what we're dealing with. This is the ambiguous case. It's where we have either one, two, or no triangles. Okay, so we have to prove which one is it. All right, so first of all, we're going to use law of sines in order to find out what the other angle is. So you look at what you've got, you see what letters are the same, right? So my two C's are the same. So I'm going to write that, and then I'm given, what am I given? Well, I'm given A, so that means I need to find the opposite of that. So that'd be sine A, right? So I'll put sine A up on top, A's on bottom. Sine of C has to be on top because sine of A is on top, and little c. All right, so now we can start filling this in. This is what we're trying to find. Sine of 82.2 over side C, which is 7.62. Okay, so when we do this here, we'll multiply both sides by 10.9 to get sine of A by itself. Okay, and I get 1.417, and it keeps on going, right? So I'm going to leave those numbers in my calculator. I'm not going to write them all out here. That equals sine of A. Well, I want actually angle A. That equals sine of A. I want angle A, so I'm going to do the inverse, right? So I'm going to do the inverse, sine inverse of this answer, which is the 1.47. But I want to leave that in my calculator so it doesn't kind of doesn't round it. Okay. And it says math error. Now, if you think about it a little bit, it says math error. Where is sine? I have an answer. Sine of some angle equals 1.4. Well, if I graph sine, aren't I only going up to 1 and down to -1? I'm never going to get up to 1.4, right? So this math error that I get, or syntax error, if you get that, that means I don't have an angle here. So if I don't have an angle, I only have one angle and I can't get another one, then it's not going to work, right? So that means I have no triangle. That one's the funnest because it's easy. But that's how you get it when there's no triangle. I'll show you some others that we do get one triangle or two triangles. Okay, let's go ahead and look at this one. So here are the two things that are the same. And here's the thing that's different, right? A. So then you'll have to use law of sines. And we want to find sine of A, right? And then since side A is on bottom, that means side C has to be on bottom here. And then angle, sine of angle C is here. Now again, you can draw the triangle. You can label this C, and you have little c. You can label any angle A, and the opposite would be here. So again, we have side, side, angle. So we have the possible 3 different scenarios that we can have. Okay, so now we go ahead and, like before, like the last example, we go ahead and solve this. And here we get 0.43, and it goes on. So I'll leave that in there. And here we can see, okay, that number's between 1 and -1, right? So then we know we're probably going to get an angle here. So I'm going to do inverse, sine inverse of that answer. So I want to leave the 0.43 and some other digits in there. So I'm going to do sine inverse of that. And I get my angle, 25.5. So angle A is 25.5 degrees. Okay, so now I have two angles. And now I can find the third by just subtracting, right, from 180. So I add 52.3 and then minus that from 180. Okay, so I get 102. So B is 102.2 degrees. So I now have A, B, and C. What was that? It's 52.3. Okay. Okay, so I'm going to draw this out for you so you can see. Okay, so this is our angle A. This is our side A. Okay, this is C. So this would be side C. And then we found B, right? And here's little b. Okay, now the thing is with this, because we know this side, or this angle, sorry, and this side, 32.5. Okay, so because we just know those two, and little c is 59.8. Okay, so because we know those two, we can figure out angle A, right, like we did, and then we found B, right? But the problem is there might be a second triangle that has the same length right in here as A. Okay, so notice what happens on this. Actually, it's not side A that is rewritten. It is the two sides that you're given, or the opposite things that you're given. So I'm given angle C and side C. So C would be rewritten as maybe that would be the same distance as C. So then I actually have two triangles. I have the big one with those same maybe B and C, right? The green one. And then I would have this blue one where this C in here would be the same length as that one. So then I still have that same length C, I still have that same side A, and I still have that same angle. So then I have this little triangle as well. So I actually have two triangles. So how we figured out our angle, right? We figured out angle A is right here, 25, 25.5. So that's for the big triangle, right? And this B, blue, this B right here would be the 102, right? So now we have to figure out these angles and see if there's a second triangle. Now, because these two sides are the same, that means their opposite angles would be the same, right? So this is also 25.5. So that means we can go ahead and subtract that from 180 to find this angle right here. And so that will give us that one. And then we just need to make sure that these three angles and this one all add up to 180, right? So, or at least these two together are smaller than 180, because that means we have room for this one down here. Okay, so I'll take 180 minus the 25.5, and I get 154.5. So this is 154.5. Now, does that plus 52 equal 180? It doesn't, right? So that means this would have to be a negative angle, and I can't have a negative angle, right? So here I'm only going to have one triangle. Okay, so here are just my three angles of that one triangle, because it didn't create an angle that's viable for a third angle inside this smaller triangle. Okay, so that kind of how it works. So when you have side angle, first you see if you have one angle to start, like the other problem didn't, right? So there's no triangle. And then once we find that the first angle, you take that first angle that you find and you take 180 and subtract it from that. And then you take that angle, the answer to that. So you have some answer there. And then you got to take that answer plus the angle that you're given. And see if it is smaller than 180. And if it's smaller than 180, then you have room for that right there. Okay, but this one didn't, so you're just going to have one triangle. So now we have three angles, and we have one side, or two sides, so we have to figure out our third side, okay? So I need to find little b, right? So to find little b, I'm going to use sine of b, which I do have now, right? It's 102.2. And I'm going to start with what I was just given, right? Sine of c, which is 52.3 over side c. And so I'm going to solve this by multiplying both sides by 102.2. So I multiply both sides by sine of 102.2. 102.2, or sine of 102.2. So I type that in, and I get 79 point, or 73.9. And so they're all my three sides. So I got my three sides, my three angles, and I'm done. Okay, so here's another one. This time we're given in degrees and minutes, so we go ahead and transform that. Just divide that 50 minutes divided by 60. So 50 divided by 60 is just 5 over 6. So we get 0.83 repeating. So 29.83 repeating degrees. Okay. And then we can go ahead and we have two sides and an angle. Again, that angle is not in between those two sides, right? So we're going to have that possible three outcomes: one triangle, two triangles, or no triangles. Well, we've already had no triangle. We have one triangle, so this is probably one with two, right? So look at what letters you're given. We're given both C, right? And we also have side A, so that means we're finding sine or angle A. So set it up. The side is on bottom. The angles are on top. Okay, so we're going ahead and multiply both sides by 8.61. So 8.61 times sine of 29.83 divided by 5.21. All right, so I get the 0.822, and it goes on. So then I'm going to do the inverse of that to get my angle A. So sine inverse of my answer, I get 55.3. So there's angle A. And now I have angle C, right? So I just need to do angle B. So 29.83 plus 55.3 minus 180. I get 94.87. Okay, so there's my first triangle. .83. Okay, so there's my first triangle, or at least the angles. Right, my sides are A is 8.61. My B I haven't found yet, and my C. Okay, so we can find B by using law of sines or cosine. Okay, using law of sines to find our B. Okay, now to find our second, right? Because basically the only thing that has to switch here is this would go to the top. I would switch those places, and then I want to put in here, I'd put in B on top and sine of my B, which is 94.87. So I put that in, multiply both sides by sine of 94.87, and my B would be 10.4. Okay, so there's first triangle done. All right, second triangle, I take my first angle that I found, which was 55.3, and I take 180 minus that. And so I get 124.7. And then I add my angle that I was given, which was C. So 29.83. And I get 154. So that leaves me room. This angle A is now going to be 127.7. My angle B is going to be the difference between, I took angle A and I added angle C, which I was given, and I minused it from 180, right? And I get 25.47. So there's my second triangle. So I find my first angle. I minus it from 180. That's how I find my potential A for my second one. So whatever angle you get, that's your first angle, and then you'll subtract a 180, and that answer is going to be your still first angle. And then you have to add up that with the angle that you're given and see if you can add and subtract that from 180. And if you get a positive, then there's your answer for your second angle. Okay, so now I need all the sides of that. Well, here's where it gets a little tricky because I still use my sides that I'm given. So my A was 8.61, so that's fine. And my C is still fine, 5.21. Now here's where I have it just my B is different. So I'm going to set up I can set up a little bit different problem here. So B over sine of B, because my sine of B is different than this equation was right here. So my sine of B would be 25 sine of 25.47, and that is equal to my 8.61 on bottom, or sorry, my C, the ones that I was given. So sine of 29.83, and then on top would be my small c, which is 5.21. So I want to multiply both sides by sine of 25.4. That gets multiplied over on top times the 5.21, and then divide by sine of 29.83. And we get for our second b is 4.51. Okay, so that's how you solve the ambiguous case, the three different possibilities. So here, when you're trying to explain what might happen, without a calculator, without using law of sines, is here. I'll do it on number 52. So you're not going to have a triangle at all if whatever angle that you're given, so if you're given some angle A, and you're given side A, well, if side A is not long enough to connect to this side, say C, angle C, so here's angle C, here's side C. So if it's not long enough to connect, then we're not going to have a triangle, right? And so this is going to happen once you're always going to find, you're going to see if sine of B is that first angle, sine of B, that one, that has to be greater than 1. Okay, so that has to be greater than 1. So what that means, if this is greater than 1, then you'll have no triangle, right? That's using the law of sines. But without using the law of sines, if I can find my height, and my A is smaller than my height, if A is smaller than my height, then I want to have no triangle because A is not long enough to reach all the way to C. If H is the same length as A, then I'll have the two triangle scenario. If A equals H, these two would be the same, and I would have two triangles, one here and then the big one, right? And if it's bigger then it's going to connect somewhere down here. So that's how you can do it if there's no law of sines. Law of sines, I can use that. If my angle that I'm finding is bigger than 1, like that first one, then we're good. We have no triangle.